holler.
I can't put my sleep
Right,
back.
so question 9 was this one. It was one of these summer method of differences things. So 1 over 3, you have to show that this first for 2 marks, that's right, isn't it? We're just going to put it over a common denominator. So for part 1, we're going to do 1 over 3r minus 1. This 1 over 3r plus 2. We would have a common denominator of these 2 things multiplied together. In order to get it over that common denominator, the first fraction we've multiplied by 3r plus 2. And the second fraction we've multiplied by 3r minus 1. There we go, that's all we need to do. The top line we can see simplifies to 2 minus minus 1. And the bottom line is that. That's it. 2 marks. Tremendous. Number 2, hence, now this had some sneaky bits going on in here, hence show that this equals that. Right. We do have some definite sneaky things that we're going to watch out for as we go through this. The first of which is that, notice this fraction. What we always do with this is we recognise how we can use the first part. But look at what we've got. We've got the sum as r goes from 1 to 2n of 1 over 3r minus 1, 3r plus 2. Right. Well, in 2 ways that's different to what we normally get. We normally just go to n, and normally this is the same as what was up here. What we need to do before we do anything else is think that actually, we'll deal with the 2n later on, but we would really like there to be a 3 on top there. Now, of course, that statement is no longer true. This isn't equal to that, unless we put a third there. And that now means that the 2 sides are the same. So, we're going to have to use that third, keep that there, deal with that later, that third, and then we're doing the sum of r going from 1 to 2n of this fraction that we had, which is 1 over 3r minus 1 minus 1 over 3r plus 2. And we're going to see what is going to happen if we put some numbers into that. Well, let's go for it. Let's keep my third there. I'm going to start with r being 1. If r is 1, I've got 1 over 2. Take away 1 over 5. If r equals 2, I'm doing 1 over 5. Take away 1 over 2, 3 would be 6, plus 2 would be 8. And quickly now we spot what's going on. If r were 3, I would have 1 over 8 minus 1 over 11. That's probably enough, isn't it, for us to recognise what's happening with this. There would be lots more terms going on there. At the end of all of this, we wouldn't come to the nth term, we'd come to the 2nth term. Now, it may help just to think about what happens with this. If we get r equal 2n, then we've got, well, 3 times 2n minus 1 would be 6n minus 1, wouldn't it? And 3 times 2n plus 1 would be plus 2 would be 6n plus 2. So the last terms, the 2 terms at the very end, are going to have those as their denominators. Before that, we would have 3 lots of 2n minus 1 plus 2 and 3 lots of 2n minus 1 minus 1. I wouldn't normally do this, but I'm just to be sure that I don't make any mistakes when I'm multiplying things out. So the terms before this are, what's that? That's 6n, and then we'd have a minus 3 plus 2. So we'd have a minus 1 there. and this would be 6n minus 3, take away another 3, so minus 4. So can we see what would happen at the other end of our sequence? We would have 1 over 6n minus 4 minus 1 over 6n minus 1, and then we'd have 1 over 6n minus 1 minus 1 over 6n plus 2. And if you'd felt like it, you could have written more terms out there. But they were the two terms for 2n, and they were the two terms for 2n minus 1. You may have wanted to do 2n minus 2, so on. What matters is that we then spot that this minus a half is there and there. We've got minus an eighth there and there. We've got minus an 11th, would cancel out with the plus 11th there. But we've also got a minus 1 over 6n minus 4, so let's cancel those out together. We'd have, that was a minus and then you're adding it. So after all that, you're left with 1/3 of the half that we had at the very beginning, take away 1 over 6n plus 2 that we had at the very end. This was a show that question. We might just about get away with saying hence at this point, just doing it. Or we could say, look at what we've got here. We've got, if we try and put this over a common denominator, or that pen, then what can we do? We've got 1/3 of, which way do I want to do this? I want to take the 2 out as well, I think. Yeah, let's do that first. So we've got a common denominator of 2 on the bottom. If we take out a half, we've got a 1/6 there of 1 minus 1 over 3n plus 1. That's probably a neat way of doing it. Which means we've got a 1/6 of 3n plus 1 minus 1 over 3n plus 1. The top line ends up being 3n over 3n plus 1. We times it by a 1/6. So the 3 cancels out top and bottom, leaving us with n on the top and 2 lots of 3n plus 1 on the bottom. And that's what we were supposed to show. So we're there. What we forgot was the third. That was what lots of people missed out on. And that was a bit sneaky, wasn't it? Right, and that's maths.